Welcome to Restoring Differential Backups. Differential backups are used to restore a database to the same state it was when the differential backup was completed. Now, differential backups can't be restored by themselves. You have to restore them on top of a full backup. Differential backups are typically used to help minimize the amount of time taken to restore a database or get the database to the point of being able to restore transaction log backups. We use differentials to make the backup smaller, so that they're quicker to back up, as well as being a little bit quicker to restore that way. So before you can restore a differential, first you have to restore your full backup. You have to restore your full backup specifying either the no recovery or the standby parameter. This puts the database into a state where additional backups can be restored on top of it. When you're doing a restore of the differential backup, you only need to restore the most recent differential. Differential backups are cumulative and such that they get bigger every time you take a differential backup until you take the next full backup. Once you take the next full backup, your next differential backup will be incredibly small again. So you'll need to take a full backup, for example, once a week, and then differential backups, say, every day, so that way your differentials get reset at the end of every week. Now, differentials are based on a very specific full backup. So you need to be very careful about taking extra full backups when you're using differential backups. Now, the syntax to take a differential backup is fairly simple. You simply take the existing restore database command that you've already got, and then you simply specify the name to the differential backup. The backup statement will be a little bit different, as you need to put the with differential syntax on the backup command. But for the restore command, it's exactly the same as it would be for the full backup. The restore process knows that the backup file that you're restoring contains a differential backup, and it therefore processes it accordingly. Like the restore of the full backup, you can specify various options like keep replication, no recovery, recovery, standby, partial, restricted user, or keep CDC. Now, for the most part, these parameters are all going to be needed only if you're bringing the database online. For example, keep replication, restricted user, and keep CDC are only useful if this is going to be the final backup that's being restored. The no recovery, recovery, standby, or partial commands are going to be more useful for every single restore that's being done. So let's go ahead and take a look at the T-SQL that we're actually going to use to do a differential restore. As you can see here, I've got a restore script up on the screen, but I've already run it so we can see the output. So you can see here I've got the full backup being restored first, restore database AdventureWorks 2012, from disk /backup/aw.back with replace, stats equals 10, no recovery. So I'm bringing the database up into the restoring state, and I can then restore an additional backup on top of it. I then do restore database AdventureWorks 2012 from disk /backup/diff.back with stats equals 10. Because I'm not specifying no recovery, the database will come online once this restore is complete. Now, I don't need to specify the replace parameter because the database is in a restoring state, so it's perfectly acceptable at this point for me to restore another backup on top of it. So let's go ahead and take a look at the output of running this statement. As you can see here, here's the output of the percentages being run for the full restore. And then you can see here the pages that were written for the full restore. And you can then see here's where the differential was actually restored. Now, the differential doesn't specify output every 10% because there was so little data to process. It just said 100% processed. As you can see, we processed 56 pages for the main data file, 8 pages for the sample group data file, and 2 pages for the transaction log file. So we processed 66 pages in 85 seconds. Now, it took a long time because it needed to actually put these pages where they belonged, and opening the backup took some time. So as you can see, the restore database processed fairly quickly. You'll notice it also only says 100% completed. It doesn't count down every 10% like the full restore did. Now, the reason for that is fairly simple. It's just because the differential was such a small backup that there's no point in spitting out the other 9 lines. So the SQL Server just gave us the 100% process just because of how few pages there were. So as you can see, there were only 56 pages for the main data file, 8 pages for the sample group data file, and 2 pages for the transaction log. Now, you'll notice it's an awful lot of time to process these 66 pages, so there's a few explanations for that. The first is these pages are kind of scattered throughout the data file. A lot of these pages are header pages, so they need to be safely offloaded and replaced. The other thing is this database is actually sitting on a fairly slow hard drive, so it would have taken quite a bit of time for that data to be moved around and for these backups and restores to be processed. So in summary, the differential, like the full backup, is going to restore the database to the exact state it was when that differential backup was completed. So any transactions after that obviously are not going to be included. Any transactions in flight when the differential backup was taken that were still in flight when the differential was completed, if we were to bring the database online at that point, would then be rolled back as part of that differential restore.